I foresee next week nobody will come because of week 14. Then we have only 2 days for study days. 2 days or 3 days. Morning. So I will basically cover 2 chapters today, which is chapter 12 and chapter 13. Alright, and then next week I will reserve for probably partner discussions, or you probably have some doubts on any chapters, then we can discuss or during the week 14. Cool, is it? Okay, so let's begin. Right. Just a recap on what we have covered last week. Right. Last week we covered the expert system. It's a computer program. Yeah, it's just a program to mimic humans making decision ability. Yeah, it's able to identify, or if you have these conditions, A, B, or this is the conclusion D. If you have that conditions, then you have that conclusion. And then I want you to focus on this. Yeah, today we will mainly focus on this part, which is the knowledge base. So I want you to recall that in most of the rules, we have 2 different types of rules. Look at the first one first. Yeah, if traffic light is red. Yeah, if traffic light is red, then stop. So can you respond like the traffic light somehow red? Is it possible to have a response that in between yes or no, or the first rules? Is it possible to have not really red or somehow red? Not possible, right? Have you ever seen the traffic light pink color? No, right? So either red or either not red, right? If you have either red or not red, we call as a classical logic or binary logic, or sometimes called Boolean logic. If you have a Boolean logic, then it's very simple. If traffic light is red, then we fire. Then we will execute this output. Yeah, anything to discuss? Assignment? AI assignment. Yeah, maybe later, later. Let me cover all these 2 chapters first. Okay. If your traffic light is not red, then we don't fire this rule. Simple, right? If I have yes, then we fire. If not, then we don't fire. But not all the rules can be answered in yes or no, or true or false. For example, in this case, did you pay attention during the class? Yes. Not honest. Just now borrow talking. Sometimes, really you say sometimes. Yeah. Not really. Depends on your mood. Yeah, understood. Yeah, it's sometimes. Yeah, maybe not really. Quite frequent. Maybe not really frequent. Yeah, occasionally. If you have this occasionally, sometimes, then how do we so-called generate the output? You pass the AI or you not pass the AI? Because your input here is sometimes. But if you have this sometimes, occasionally, then this term is called uncertainty. Uncertainty. You have this uncertain words here. Then how a good expert system to reason this uncertainty and generate a proper output. So that is the challenge in the expert system. So we have 3 typical solutions to tackle the uncertainty. We use the typical methods called probability, right? Because that we know that probability is a value in between 1 and 0, right? It's a chance, right? It's a chance. So you have a near to 0, then it means that the chance that it happens is very slim, right? If the value near to 1, then the chance that this event happen is very high. Then if you have a value in between, means that you are not very sure. The chance that it happens is 50-50. You don't know. Okay, so that's the reason why we use a probability to provide the spectrum, a value in between yes or no. Instead of set a cutoff line, yes or no, right? So this one we have some value in between yes or no. We have a second technique using a more simple technique we call certainty factor. Okay, so certainty factor compared to the probability is much more simple, because probability you need to collect a lot of data set. Yeah, you need to collect the probability that this event happens, that event happens, like the one that you have learned in the Bayesian theorem, right? You have to collect. But certainty factor, you do not need to collect much of the information. We just need to convert some uncertainty to some numerical value, which I'm going to cover in more details later. Right, so the value bound between the certainty factor is different than the probability. Is between -1 to 1. Right. Then the last techniques, we use fuzzy logic. Okay, fuzzy logic, the value bound between 1 and 0 as well. Right. So, but we have a term to describe this spectrum. It's called degree of membership. Okay, so we have 3 techniques. I'm going to show you one by one how to use the probability, certainty factors, and fuzzy logic to identify the spectrums or the values in between yes or no. Okay, alright, so yeah, that is the theory a little bit behind the scenes here. So we have a classical logic where you have a true or false. Uncertainty is you have some value between true or false. Okay, just like toss a coin, that where you toss a coin is impossible to you to get answer or output in between a tail or the head, right? It must be either tail or either head. It's not possible to have in between, right? So this one is known as classic logic. Okay, so why there is uncertainties here? We have 2 resources. The first one is called imprecise language. For example, frequently, sometimes, often, occasionally. Unknown data, for example, I don't know, I'm not sure, I don't understand. Okay, so a good expert system should be able to reason all these uncertainties and provide appropriate output to you. For example, in this case, if the expert system asks, do you feel dizzy? Okay, maybe you say, okay, sometimes. Your heartbeat unordinarily fast? Maybe you say, it depends. It depends. Do you have insomnia recently or quite frequent? Then this expert system should be able to reason all these uncertainty and to generate you some output. Yeah, probably you're falling in love. Okay, you feel dizzy recently? No. Insomnia? No. Your heartbeat? No heartbeat. No heartbeat. No heartbeat. Okay, thank you. Alright, so how this happens is actually we have to, when we receive this uncertainty, the machine will actually convert to some numerical value first. Okay, convert to some numerical value, process this value, and to generate some output which is in numerical value, and then we convert it back to these strings. Yeah, I want you to come back, recall the NLP. Yeah, how the machines process the string. We have to convert to some value first. For example, the TF, ITF. Right, so the machine cannot process the string, so we have to convert to some value first. But I'm going to show you later on how to convert and then to perform some calculations and to generate some strings. Okay, so let's look at one of the first solutions, probability theorems. Yeah, as I mentioned just now, the value bound between 0 to 1. If 0 means that the chance that it happens is very slim, and if the values tends to 1, then is the chance that it happens is very high. Okay, so one of the common probability that we use here is called conditional probability. Yeah, so probably this you have learned this in your Form 4, Form 5 maths. Yes. Do you recall this? What is conditional probability? And what is this? That's your understanding about conditional probability. Oh, very good. Yeah. So it means that an event happens depending on a certain conditions. Yeah. For example, yeah, student attend the class. It depends on the probability that whether it rains this early morning. Right. So that is how we write. This is your conditions. Okay. So that is your condition. Okay. Okay, so this is conditional probability. You have A depending on the B. So B happens and then it will affect whether you will attend the class or not. It's called conditional probability. It's affecting each other. Okay, so this is some derivations of conditional probability, very quick ones. right? So let's say you have A depending on the B, and it's actually equal to A intersect B, yeah, divided by PB. Right, so this is two equations. We can also change these positions where you have B depending on A is equal to P B intersect A divided by PB. Right, so this is the first equation, so this is the second equation. So what we can do here is we can actually put this to denominator to the left hand side. So it becomes P A B equal to P A multiply PB. So this is from the first equation, right? So you will get this. So same from the second equations, you can this denominator you can put at the left hand side. So you will get P B A equal to P B A multiply P. This one is A, B, A. Okay. Okay, so we know that this P intersect B and P intersect A is the same. It's going to give the same value. Alright, and then we can just substitute these equations. Let's say 4 into 1. Right, if you substitute this into the 1, then you will get P A B equal to P B A multiply P A divided by P B. Okay, so this is known as Bayesian theorem. Do you have any memory on this equation that you have learned in chapter number 6, the machine learning course, one of the topics, right? Bias. This is how we derive. We have this simple conditional probability we can derive, and then we can use this to predict the input, the new input. If you still remember, we have a PHD equal to PDH multiplied PD divided by PH. Okay, so don't worry about this. You don't need to remember the derivation. I just want to show you that how to get this Bayesian theorem, the way you have learned in the chapter number 6. We just do simple substitutions. Okay, so how do we use this to calculate the uncertainties here? So we have some certain examples. Alright, look at these simple questions. We're going to remain these equations. Okay, so if it was raining yesterday night, then the backyard is wet in the morning. So if it was raining, so the if part, if part is the condition. So if you represent in the conditional probability, it would be if it rained yesterday night, so the backyard is wet. So this is your hypothesis, your output. Given that it rains is equal to 0.7. So it's given. So it rains 200 days in a year, so the probability that it rains is equal to 200 divided by 365, because 1 year you have 365 days. 60% chance that the backyard is wet is equal to 0.6. So you have all these assertions, all the information here. Now the question is, if the backyard is wet, what is the chance that yesterday night rained? So it means that you sleep today, tonight. Okay, you sleep. So the next early morning, you wake up. Okay, you look at your backyard. So the backyard is somehow wet. Alright, so that is the condition. You sleep. You don't know what happened yesterday night. You wake up, you look at the backyard, it's wet already, right? Then you have to guess. What is the probability that this wet is caused by rain? You have to find out, given that the backyard is wet, which is your observations, what is the probability that this wet is caused by rain? Your hypothesis. So this is what you have to find out. Alright, so if we use these equations, assume that this rain is A, the wet is B, is equal to PBA, which is P wet rain multiply P rain divided by P wet. Okay, so you have these three values given here, then we just substitute. 0.7 multiply rain is 200, 365, 0.6. So give me this answer. Use the calculator. Okay, where's your agent? Today you look pretty good. Much better than us. Enough you. 0.639 is like around 64 0.64. It means that if yesterday night you sleep, you don't know what happened, right? And then this early morning you wake up, you see the backyard is wet. And then the chance that this wet is caused by the raining is 64%. The remaining 36% could be caused by other factors that we don't really care. But it caused by the wet is caused by the rain is 64%. The probability we talk about probability. Right? Instead of saying yes or no, yes, it's caused by rain or not caused by rain, we have a spectrum in between yes or no. We have 64% chances that the wet is caused by rain. Okay. Alright, so that is the simple example showing how to use the Bayesian theorems. Right, so but you have to always remember, not all the times we will get this probability. So this is called hypothesis probability. It's not all the time we will get this probability. Sometimes it's not given. Yeah. So look at the second example. Okay. So let me clean this first. Okay, same situations. If you see the grass in the backyard is wet in the morning, right? You look at these questions. You sleep, yeah? You sleep. Next day, you wake up. You see the glass or the backyard wet in the morning. So you have to use Bayesian theorems and to identify what is the probability that this wet caused by drizzle or is it caused by rain? So you have multiple hypotheses. In the previous examples, we just want to predict whether it is caused by the rain. Now you have one more factors here, which is drizzle. It can caused by rain or it can caused by drizzle. So you have to find out what is the probability that this wet caused by drizzle, and you have to find out this as well, and then you compare. Okay, so if you substitute this equation, if you expand, so you will get P wet drizzle multiply P drizzle divided by P wet. So same go to this one, P wet rain multiply P rain divided by P wet. Right, so now your task is to find out what is the value for this. So these are your data set. That's why I would say Bayesian theorem is a bit tedious, because you need to first collect all the occurrence of frequency first. So how to get all this information from the rules, right? If that was a drizzle last night, right? If there was a drizzle is a condition. There is a 60% chance that is wet, so it's equal to 0.6. If there was a rain last night, 80% chance. Rain last night, 80% chance is wet in the morning. And then we have two more informations. Drizzle probability is 160 day 365. And then we have rain is equal to 120 365. But you will notice that we have these values, but we do not have this value. Right? We do not have this value, and it is very common. If you don't have this value here, doesn't worry, right? So because we just want to compare the value, So we can just simply substitute this value using this conditional probability. It means that we just combine this conditional probability as your denominator. Okay, so this is your first conditional probability. You have to add up with this p right ring multiply p ring. That's it. So same goes to this one. We have a p right ring multiply p ring divided by, so this one duplicate this as your denominator, and we just, okay, the reason why I can just simply change this one because we just want to compare this, and your denominator is actually a constant. It's just a constant. So we put this as your denominator so that we want to make it property as equal to 1. Okay, then you substitute the value. P back Drizzer is given. Drizzer is given 160,365. Okay, so equal to multiply 160,365 plus 0.8 120,365. Then you will get this one. So you have to do this for the another case also. Right? Help me to calculate this. Right, same so this is actually a PA B, this is a PBA, multiply PA divided by PB. See, we use this equation to find the chance. Okay, so this one you will get 0.5. How about that one? Also, okay, so this one you will get 0.5 as well. So in conclusion, if you sleep yesterday night, this early morning, the backyard is wet, then the chance that this wet caused by drizzle and rain equally same, which is 0.5, 50%. It could be 50% caused by rain, 50% caused by drizzle. Okay. So this probability method is a bit time consuming. First thing first, you need to collect this all informations. You need to collect, okay, one year, right? In 1 year in Malaysia, how many days actually raining, how many days drizzle, and then if let's say drizzle last time, what is the chance that it wet? So you need to collect all this information. Then only we can find out this value. Right. So, now I'm going to introduce you another more simple techniques. Okay, it is known as substitute factors. Alright, so for the start, make sure that you know how to do this kind of questions and try to understand the theory behind the substitute factors. Okay, so I'm going to clean this board up. Okay. Alright, so just now we have seen the probability is the value bound between 0 to 1. Right? And then what is certainty factors? You have to assume that this certainty factors is about the how sure, how certain. Yeah, how sure, how certain a given statement is true. Yeah, how sure. The probability is about the chance, right? So the certainty factor is how sure. Alright, so forget about this. Right. Okay, look at this. Let's say now, if you still remember in the expert system, we have one important module. It is known as the knowledge base. Right? So in the knowledge base, it store all the rules. Store all the rules. And then how to prepare the rules? You have to interview with the experts. For example, doctor. Right? Let's say now you interview this doctor. The doctor tell you, okay, if I see this symptom, okay, if I see this symptom, which is the X, then this may be, the doctor also not sure. This may be a disease Y. Okay, so if the doctor also not sure, if you have X, maybe it is Y, then we would like to provide a certainty factor to these rules. Alright, so maybe you can convert using this table. Don't worry about this table, no need to memorize this. I just want to give you some example. Let's say the doctor say, if I see this symptom, then maybe it is disease Y. Then maybe is what? Maybe we convert to some numerical value, then you have a certainty factor of 0.4. It means that when we see this rule, we know that if you have this X, then maybe you have this disease. Alright? If the doctor say, okay, if I have seen this X here, for example, some eczema, some of the red spot, okay, I'm pretty sure, I'm very sure that this is eczema. Then I'm going to give a value called 1, because the doctor very sure, very certain, right? It's called certainty factor. If the doctor say I'm maybe, then it's become 0.4. Okay, so the doctor say, oh, probably is a Y, then it is a 0.6. We'll assign this value to these rules. Okay, alright. So now next, continue. Okay, assume that you have this rule here. Alright, so now I may ask you, okay, so what is the, how to say, let's say you are the patient, you are the patient. So X here is, let's say, the risk spot. Let's say it's the risk spot. So Y is the eczema. Then I'm gonna ask you as a patient, how sure that your risk spot, how sure that you probably like see the risk spot on your body? How sure? Maybe you see that, okay, every day, almost every day. I'm very sure. Okay, so you are very sure or you are very certain for a certain input, then we will give a certainty factor to your input also, which is 1.0. Which is 1.0. Okay, if you say, okay, maybe sometimes I see a risk spot, sometimes not, I didn't see, sometimes, maybe. Then I will give input as 0.4 as well. So it means that your input could have certainty factor as well. It's not certain, but you have some certainty factors. You have a value in between -1 to 1. Okay, issue, right? So in this case, first we have a rules. We will provide a certainty factor to these rules. Next, we will ask the patients, right? The patients will give us some, let's say, maybe sometimes we have to convert that conditions to some certainty factor as well. Okay, so now the question is, how do we propagate the conclusions? Well, how do we get the conclusion? We just simply multiply the certainty factors of the input with the certainty factors of the particular rules. Then we will get certainty factors of the output, which is, you have a 0.4 input, we just simply multiply the 0.6. Where's the answer? 0.24. 0.24 what in this case? You just simply multiply the certainty factor of your input with the certainty factor of your output, then you will get 0.241. So what is 0.224? Then if you convert back to the string, is 0.2 is really like unknown. The expert system will say, oh, unknown. Even the certainty factor also not sure. You are not sure that it is. You have this y thesis or axima. Okay, if you compare to the probability, this certainty factor is much simpler, right? Because we just need to get the certainty factors of the roots and certainty factor of the input, then we multiply them. Okay? If okay, then we move a little bit further, right? So sometimes you can have more than one root. Yeah, in this case, if n, x, and let's say c, you have two conditions here. Alright, and then we have two certainty factor for this input. For example, I ask the patient. The patient said maybe, then we have this 0.6. Maybe we have another value 0.8. Okay, so how to do the propagation? When I say propagation, means that how to do the multiplications. We have two values here. Then we have to look at this operator. If you have more than two conditions, you have to look at this operator. If n, then we use minimum value. Means that we choose the minimum value between these two certainty factors and do the multiplications. If you have an all value, then we use maximum value. We choose the maximum value between these two certainty factors and multiply this 0.6. Right, if in this case n, so n here we use minimum, which is 0.6. We just simply 0.6 multiply 0.6, you will get 0.361. Okay, so if let's say this is all then maximum. So which one is maximum? 0.8. Then we don't use 0.6, we use 0.8. 0.8 multiply 0.4, 0.481. Okay? Simple mathematical calculations, multiplications. Okay, so now let's try some exercise here. Okay, your senior come up with these rules, right? If you do exercise or you do assignment here, then you will pass the exam. The senior say, I'm sure if you do exercise, if you do assignment, you will pass the exam. I'm pretty sure. Yeah. So I assign 0.9 certainty factor to these rules, right? And then if now I ask you, okay, EJ, how sure that you will do exercise? Maybe you say 0.8. This semester is quite busy, but I'm still pretty sure that I will do exercise. We have 0.8. How about assignment? You will say 0.7. I have too many assignments, so I'm 0.6. I'm also I'm quite I'm like what 0.7 here. Maybe I'm almost certain. I'm almost certain we do exercise. So you have a two value here. Then you have to look at this operator. We choose maximum value, which is 0.8. We just multiply the certainty factor of this rules. Right? 0.8 multiply 0.9, you get 0.72. 0.72, you will pass the exam. 0.72, you pass the exam. What do you mean by 0.72 pass the exam? Yeah, it's probably. Yeah, probably. But you don't really need to convert back to the string here, but you can just write 0.72 pass the exam. Okay? If okay, I move a little bit deeper, further. Okay? Alright. So this one no problem. Okay, sometimes you could have these conditions where you have more than one rule lead you to the same conclusions. If you have X, then it gives you a Z. If you have Y, it gives you Z as well. So let's say you have certainty factor of 0.7, you have a certainty factor of 0.8, let's say in this case. You have rules number 1, you have rules number 2. So look at this properly, you have two different rules but give you same conclusion. Both lead you to Z. Okay, so how to solve it? So first, if let's say now I collect the data, okay, someone say X, I have a 0.6, so Y, I have a 0.5. I will just simply multiply this one first. So certainty factor for root 1, you will get 6 multiplied 7, 0.42Z. And then root number 2, you will get 0.4Z. So how? Which one is your final conclusions? You have 0.42Z, you also have 0.4Z here. You have two conclusions. So if you have these conditions, you have to combine them. You have to combine these two certainty factors. Right? To combine this, you have to use these equations given here. You have to check the sign of these two values. If both are positive, then you use the first equation. CF1 plus CF2 minus CF1 multiplied CF2, which is 0.42 plus 0.4 minus 0.42 multiply 0.4. That's it. This is your final conclusions. I repeat, if you have this one of it is like negative, let's say, assume that you have one negative, you have one positive. Then you have to use the third equations. CF1 plus CF2 divided by 1 minimum modulus CF1 more CF2. So in other words, if you have one negative, one positive, so this is negative 0.42 plus 0.42, 1 minus minimum, then you choose 0.42, 0.4. So this is the equation. If one of it is negative, another one is positive, then you have to use the equation number 3. If both of value here is negative, then you have to use equation number 2. Don't worry, this equation will be given. Yeah, no need to memorize the equation. You just substitute into this. Not sure about that. 0.5. You're not sure then? Certainty factor, if you are not sure, the value is 0, because the value is between 1 to negative 1. Okay? So if probability, if you're not sure, then 0.5. Certainty factor, if you're not sure, then it's between value 0. Okay? So if you will understand everything this. I repeat, I'll make a summary here. So how to do a propagation here? Simply use the certainty factor of the input, multiply the certainty factor of the output. First thing you have to remember. The second, if you have more than one condition here, then you have to check this operator. If the operator is all use maximum, choose the maximum value. If n, you choose the minimum value. So the third thing that you have to remember is sometimes you can have rules that lead you to the same conclusions. Then you have to use these equations to combine the certainty factors. Okay? And then the last one is sometimes you can have more than two rules, like rules number 1, A lead you to B, lead you to Z. Okay, rules number 2, B lead you to Z. Rules number 3, C lead you to Z. You have 3, you have more than 2. But you look at this equation, you have only 2. You have only 2 variables to substitute. So what you have to do, you just simply combine this R1 and R2 first. You will get some certainty factor. Then you combine this with the rules number 3. Then you will get another combined certainty factor. You combine. You solve the R1 and R2 first. Then after that, you combine with R3. Okay? So, to test your understanding, let's try some questions here. So this is one of the past year questions. Can you try this? The following is the rule base for early detection of depressed final use due to it. You have rule 1, 2, 3, 4. So these are the rules. And this is the so-called the observations.